This video is the Unit 2 Quiz Review Study Guide, numbers 1 through 4. Number 1, it says if two angles form a linear pair, then they are supplementary. So we're given the statement that angles ABC and angle DEF form a linear pair. Using the law of detachment, we're then able to confirm or argue that if they form a linear pair, then these two angles must be supplementary. So that would be our conclusion. Angle ABC and angle DEF are supplementary. When you use the law of detachment, remember that if you're going to make a statement, you've got to be given the statement that is the hypothesis of the if-then, the conditional statement. We can't give you the conclusion for you to be able to argue the hypothesis. It's always got to be given with the hypothesis because then you can make the conclusion. All right, number 2, if two angles are vertical angles, then the angles have the same measure. If two angles have the same measure, then they are congruent. So we've got two conditional statements, which means we're going to be using the law of syllogism, which means we can say if this is true and this is true, and if that is true, then that is true, then the initial hypothesis and the last conclusion can also be true. So if two angles are vertical angles, then they are congruent. So again, what we took was the initial hypothesis and the last conclusion because these two middle statements had the same value. They were the same meaning, or in other words, they were the same kind of sentence. All right, number 3. So on number 3, we're supposed to be looking at these statements. We're going to be writing the converse, inverse, and contrapositive, and then we're going to decide the truth value, and then, if possible, we're going to write the biconditional. So in our initial conditional statement here, it says, if a rectangle has 4 sides of the same length, then it is a square. That's true. So then we have the converse. The converse occurs when we switch the hypothesis and conclusion. So if a rectangle, now we're going to take the conclusion, is a square, then it has 4 sides of the same length. So if it's a square, then it has 4 sides of the same length. Well, that is true, which means I can go ahead and write a biconditional for this statement. The inverse. Inverse means when we negate both the hypothesis and the conclusion. If a rectangle does not have 4 sides the same length, then it is not a square. Which is true, and I know that because my converse and my inverse will always match in truth value. The contrapositive is when we flip the hypothesis and conclusion as well as negate. So, if a rectangle is not a square, then it does not have 4 sides of the same length. And again, this is also going to be true, but I can confirm it because if my original is true, the contrapositive will match in truth value. So now I can write the biconditional because both the original and the converse were true. So the biconditional would say, a rectangle has 4 sides the same length if and only if it is a square. Number 4, if measure of angle A is 70 degrees and measure of angle B is 20 degrees, then A and B are complementary angles. So the converse would mean we would switch the hypothesis and conclusion. So if angle A and angle B are complementary angles, then the measure of angle A equals 70 degrees and the measure of angle B equals 20 degrees. Now, let's look at the original statement here. The original statement says if the measure of angle A is 70 and the measure of angle B is 20, then they are complementary. The definition of a complementary angle is that these would add up to be 90 degrees. So if that is exactly what measure of angle A and B are, they would be complementary. So the original statement is true. However, if we look at the converse, if we know A and B are complementary angles, that's given, that's a fact, then it must be the case that A is specifically 70 degrees and B is 20 degrees. Well, that's not true because A could be some other measure. Like A could be 60 degrees and B could be 30 degrees. That would still make them complementary angles. So our converse is actually false. Now let's go ahead and look at the inverse where we negate this. So if the measure of angle A is not 70 degrees and the measure of angle B is not 20 degrees, then angle A and angle B are not complementary. Well, let's suppose that the measure of angle A is 60 degrees. That means it's not 70. Let's say it's 60 degrees. And B is 30 degrees. Again, it's not 20, so it's meeting the parameters here of our hypothesis. If this was 60 and this was 30, they would be complementary angles. So this is false, but we can confirm it because the converse and inverse should match in truth value. The contrapositive would be to flip and negate. So if angle A and angle B are not complementary angles, then measure of angle A is not 70 degrees and the measure of angle B is not 20 degrees, which can uphold, it can be true in this case because as long as they're not complementary angles, we know for a fact these can't be their measures. The big word here is and. It has to be true for both. So, and I should have put a not there. So this would uphold, but again, I can confirm that because my original and my contrapositive should match in truth value. Now, in terms of the biconditional, the original and the converse both have to be true. So if you look, since the converse is not true, there is no biconditional statement for this particular conditional statement.